Welcome back everybody. In this video we're going to talk about the volume of a sphere using this formula right here, 4/3 pi r cubed, where r is the radius. Let's do a few and see how it works. Here we want to know the exact volume of a sphere. Let me get the formula written again. 4/3 pi times radius to the third power. So in this problem, the radius is 6.5. We're substituting that in. We take 6.5 times itself, we get 274.625 times 4 divided by 3 comes out to 366.16, repeating. The 6 repeats, and we're going to keep pi in our answer. And the label would be cubic feet. So when you want exact volume, they usually want you to keep pi in the answer. Here's an approximate where we will use 3.14 instead of pi. So here's that formula again. V equals 4/3 pi r to the third power. We will have 4/3. Instead of pi, we put 3.14, and the radius this time is 3. 3 will be raised to the third power. Putting that in a calculator, we end up with 113.04 inches cubed. Alright, let's look at an application of it. We have two spherical balloons filled with water. The first balloon has a radius of 3 centimeters, second has a radius of 6. How much greater is the volume of water in the larger balloon than in the smaller balloon? We'll use 3.14 for pi, or round if necessary. So basically we need to figure out two volumes. The bigger spherical balloon minus the smaller. If we subtract those two volumes, we will get our answer. So the first one, 4/3 times pi, and the radius is 6, so 6 to the third power. Go ahead and calculate that in the calculator. You can enter 4 divided by 3 times 3.14 times 6 times 6 times 6. We will get 904.32. And then the smaller one, 4/3 times 3.14 times 3 to the third. So in the calculator, once again, 4 divided by 3 times 3.14 times 3 times 3 times 3 comes out to 113.04, similar to our previous problem on the other screen. So in the calculator, 904.32 minus 113.04, we're going to get an answer of 791.28. So there is that many more cubic centimeters in the larger sphere than in the smaller sphere. Let's look at one more application problem. The non-scale model of Earth has a diameter of 18 inches and an outer clay layer. Kind of model that here. And then there's a core made of a ball with a diameter of 3 inches. Alright, so this is the scale model of Earth. Please note that there's talking about the diameters. So this diameter of the outside model of the model is 18, but the diameter of the inside is 3. Now when you use the formulas for the volumes, you need the radius, not the diameters. So on the outside here, the radius would be 9, and on the inside the radius would be 1.5. It's 3 divided by 2. So they want to find the volume of the clay. That's this area here, this part here. We're going to take the outside volume and subtract it from the inside volume much like we did on the previous example. So the outer minus the inner. Alright, so the outer would be 4/3 times pi times the radius to the third, that's 9 cubed, 4/3 times 3.14 times 1.5 cubed. And a little hint for doing this, you can actually, if you have the ability to put parentheses around each one and you enter this in the calculator, you can do it all in one step. I find you think you'll get an answer of 3,037.95, and that would be cubic inches. So again, on this example, it was the volume of the outside sphere, outside of this model of Earth, minus the volume of the inside. A little bit of an extra step by finding the radius after dividing diameters by 2. Hope this helped. Thank you very much for watching.